and this trolley has carried a load of 3 kilonewton. You have seen such structures. For example, maybe in the factories or in some areas, you have seen some trolleys or some cranes which just took the load and move along a line. So it is something like that, and you can see such cranes in industrial buildings, or sometimes maybe in car wash, sometimes maybe in a warehouse. So and because this load is a moving load, this load is a trolley or a crane, so we have to see the effect of this load, because it will not remain the same when the load will move. Okay, so what is the question? If anyone of you can read it. What is the question?
The frame structure shown in figure 611A is used to support the hoist for transferring loads for storage at point under it. And then it is anticipated that the load on the dolly is 3 kN and the beam CB has a mass of 24 kilograms per meter. Assume the dolly has negligible size and can travel the entire length of the beam. Also assume A is a pin and B is a roller. Determine the maximum vertical support reactions at A and B and the maximum moment in the beam at D.
Okay, so one information, the self-weight of this beam is 24 kg per meter. Is it correct?
Yeah.
Number one. Number two, the A is pin.
And B is roller.
Yes. B is roller. So what we can do, we can I'm just going to eliminate this part. Okay, like this. And so it fills, solid fill, but it should be wide, line, here, so C. Okay, so here we have what type of support pin?
Roller. Roller. B is roller.
Roller. And here we have a hinge. So it means this frame is not a rigid frame. This frame has like a roller support here and a hinge support there. So what we have to do, we have to find out the moment at point D, and what else? The reaction at A and B.
Yes.
So we need the reaction RA, the maximum reaction RB, maximum, and moment at point D maximum. So we have to find all these things. Okay, I tell you a very important thing. Why we draw interest line diagram? I told you in my first lecture. Why it's unit load only? We draw the interest line diagram for unit load. Why?
To study each meter, each place.
Yes, fine. So, what is the benefit of applying one unit load?
Find the moment at one load.
If we apply a unit load, we have a diagram for one load. So if we want to get the total effect for any load, how we can do that? We can just multiply the load with the value and we can get the total force. Did you understand? Today I will teach you how how you can apply the loads, how you can, for example, in this case now we have two loads. Number one, self weight of the beam, 24 kg per meter, which is UDL, and the other load is 3. So we have to find out the maximum reaction at A, maximum reaction at B, and the maximum bending moment. But before that, must have the influence line diagram for all these three things. So first step, we have to draw the influence line diagram for RA. We have to draw the influence line diagram for RB and influence line diagram for B. So the influence line diagram will be drawn for unit load. So let's draw it. I think now you are expert in drawing the influence line diagrams. This is what I think. And this is for RB. And okay, this is for the moment. So first of all, you can consider a reaction here. You can call it RA, and you can call the reaction here as RB. Next, you can draw this influence line diagram by any way. Either put the load at this point, find out this reaction, or you can make your equation, you can make a function. So, which way you would like to consider right now? Equation? Okay, so let's put the load here, somewhere here. Okay, and that will be the function of x. For example, if the load is here or here, if the load is at this point at x, so how much will be the reaction? You have a unit load at this point, 1 kilo, just 1. So, what to do now? If this is x, how much will be this distance?
1 minus x.
Okay. So let's take moment at point B. So RA into 3 should be equal to 1 into what?
1 minus x plus 3.
1 into 4 minus x.
You can say 4 minus x.
What about the self weight? Do we ignore it for now?
Ignore it right now because we are drawing the influence line diagram and that's for the unit load. Okay? Don't consider this load till now because we are drawing the influence line diagram. Okay, so how much will be RA?
4 over 3 minus x over 3.
4
Minus
Over
x
3.
over
4 over 3,
Yeah, minus x over 3.
or you can say 1 over 3, 4 minus x. If x is 0, and what about RB? It will be 1 minus RA,
Yeah.
and that will be 1 minus
1 over 3 into 4 minus
1 over
3 into 4 over minus.
this.
So it should be x over 3 minus 1 over 3. Yes.
Okay, it's fine. When now it's very easy to draw the influence line diagram. I mean, the quick way. When let's draw first 4. Just keep. I'm going to write these equations here. Remember these equations because I have to use this space RA is equal to
1 over 3, 4 minus 6.
RB is equal to
X over 3 minus 0.33.
But there's a very easy and quick way. For example, when load is here, the unit load is here, how much will be RA?
Maximum.
Which is
How much will be RA?
1.
If the unit load is here, here the load is 1, how much will be RA? 1. And if the load is here,
0.
how much will be RA?
0.
And when the load is here, how much will be RA?
So X is 0.
Just put X.
1.33.
So,
1/3
means
higher than.
it is straight line. Okay, don't confuse it with my drawing.
Okay.
Because it's a little bit lengthy line and it looks like a curve. So it is 1. And here it will be
1.33.
1.33. This point is how much? 1.331. This is the inverse line diagram for RA. It's very quick without writing any function. Okay, when the load is here, how much will be RB?
0.
0. And when load is here, how much will be RB?
1.
One. This is not 1.33. And when the load will be here, how much will be RB?
Negative 30. Negative 30.
Minus 0.33. Good. So you have drawn the inverse line diagram for RA and RB. Now what is left? Moment. So we need 3 points, 1, 2 and 3. Instead of writing for like every 1 meter, 2 meter, we need 3 points. How much will be the moment here? For example, if the load is here at point C, how much will be the moment at point D? If unit load is at point C, how much will be the
2.5.
Okay, do one thing. Put x is equal to, put x is equal to what?
0.
No, 2.5. If x is equal to 2.5, how much will be RA?
Which point number 3?
Third into
0.5. 0.5. Is it correct? Okay, it makes sense. It means when the load is here, it is half, it is half. And when the x is 0, how much is RA?
4 over 3. 1.33.
1 point. So if the load is here, I mean what we need, make yourself very clear. We have to draw the inverse line diagram for moment. We need 3 points, 1, 2 and 3. What we will do, we will put first load here and we will find out the moment at point D. We will put the load here and we will find out the moment at point D. And then we will put the load at this point and we will find out the moment at point D. It's very easy. If the load is at this point, you have this reaction. How much will be the moment at point D? when x is 0, how much will be the moment at point D? It's very simple. Your load is here.
Yeah.
So 1 into how much? 2.5 minus reaction
1.33 into 1.5.
into
1.5.
so what is the answer?
Teacher, also RB.
RB no. We are just using a section from left.
Okay.
If you want from RB, okay.
0.505.
What is the answer?
Almost 0.5.
0.5. Minus or plus?
Plus.
Minus.
Minus.
Will be minus.
Will be
Minus.
It should be plus or minus. Please check.
The book minus.
So what we are getting?
Everything plus.
Positive.
Positive.
Yeah. Because
We should change this.
no, because I'm considering this way. See, the moment due to load is negative and moment due to reaction is positive. So, if you take on the other side, the moment due to reaction is positive and moment due to load is, so it will be minus 0.5.
Minus 0.5.
Okay? So, when x is 0, you have minus 0.5. X is 0, MD is minus 0.5. And when x is 1.5, how much is RA? 1?
Teacher, 1 or 1.5?
Sorry, when x is 1, not 1.5. When x is equal to 1, how much will be RA? 1. And how much will be the moment at point D?
0.
0.
1 is upward, 1 is upward.
Yes. If load is at point D, here, how much will be the moment? 1. If the load is at the center, how much will be the moment at point D?
So x is 2.5.
Let me tell you, because listen, if we have the moment, in case of moment, we need one more point here. We need the influence line value at this point, because the moment here is 0, the moment here is 0. So in order to find out the moment diagram in between, we should also find out the moment value at this. So in that case, we need at least 4 points. For reactions, we need 3 points. For the moment, we need 4 points. How much will be if the load is here at the center, how much will be the moment?
0.75.
You can calculate, I don't know. 0.5 into 1.5.
It's 0.5.
0.75.
Okay. So you have this point, this is 0.75, and then this point, just connect this with this point, 0. Yes.
Why do you consider 1 not 2?
Sorry?
Why do you consider 1 not 3? The 3 kilonewton.
Forget about 3. I'm telling you, first you have to draw the influence line diagram.
Okay.
Let me take it a little bit up.
Should this be in negative or positive? The 0.75.
I think it should be positive. For example, this diagram shows an influence line diagram for RA. Is it same? Yes.
Same.
Okay. And this shows influence line diagram for RB. And this shows influence line diagram for MD. Is it same?
Yes.
Yes. just put minus 0.5. So once you have this, now how to find out? Now what is the question? What do we need? We need the maximum reaction at point A, RB and MD. Now I'm going to tell you how you can calculate these three things. It is an important point. And the beam cell weight is 24 kg per meter. How much kilonewton per meter? So convert into kilonewton.
941.
940.
0.941.
kilonewton per meter. 1.5.
It is
235.
235.44.
Okay. So now we have the influence line diagram. I'm going to erase all these things. Next part is very easy. Next part is very easy. Just you have to put your concentration. Tell me 1.33. Okay, tell me the UDL is present where? The UDL is present at one point or on the full length? Full length. So it means the UDL is present on the full length of the beam. But this point load is moving. Now the first thing we need, number one, maximum RA. So how much will be the reaction due to this UDL? How you can find it? Just multiply the load per unit area. It will be 0. How much kilonewton per meter? 235 kilonewton per meter. Yeah, it will be something like this. Multiply by this total area because the load is present on all this length. So the total area of RA.
So 166. Will be 2.66.
Multiplied by 4. This is the total area of this diagram. So now
It's 0.235.
this 0.235 is the self weight W. It was 24 kg per meter. Convert into kilonewton.
Yes.
This load is present on the full length of the beam. Okay. So multiply this load by this area. This load, why I'm multiplying by this area? Because this load is present on the full length. So this is the reaction due to UDL. Now the reaction due to this load, 3 kilonewton. When you will be having the maximum reaction? When this load is where?
On the earth.
When this load is here,
Yeah.
you will have the maximum reaction.
No.
When the load is here,
Yeah. Reaction itself on it.
I mean, you will have the maximum reaction when the load is here.
For RA, yes.
Yes, for RA, yes.
No.
No.
Here.
1.33.
When the load is here, the reaction was 1.33.
Yes.
Do you understand?
Yes.
When the load is here, then you will have the maximum reaction. For example, in order to find out the maximum reaction, where the load should be at this point. So how you can get the reaction? 3 the load multiplied by this coordinate over 6. That's all. So you will get the maximum RA. Please check how much is that.
Point six.
4.6.
4.6 point, whatever.
4.6.
4.62. Done. Maximum RB. The UDL is present all on the length. You cannot change the UDL because it is a surface. But this load is moving. So how much will be RB? The
0.3.
Now remember here, this area is negative and this area is
Positive.
positive. So how much will be the total area, resultant area?
This minus that.
So you have to calculate the same way the UDL multiplied by the total area. So plus area with the plus sign, minus area with the minus sign. So the plus area is 1 over 2 into 1 into 3. 0.5 or how much was this point? 0.33
Yes. Minus.
into 0.33 into 1.
Will be 1.331.
Yes.
Plus.
But when you will get the maximum reaction
That's B.
At B.
when the load is
At B. That's all.
Acting on B.
yes, so plus 3 into
1.
1. So how much is RB?
Three point 3.14.
3.314. Just 1 minute. Let me fix all this. What is the answer? Is it same in your book or not?
Yes.
Okay, now the moment. The same way, when you will get the maximum moment. The UDL is present on the full length. The UDL is present on the full length. So in order for the UDL, you will calculate this total area, plus minus negative. Okay? And when you will get the maximum moment due to point load?
That's B.
When the load is here?
No.
Here?
Yes.
Okay. So the moment at point D, I write it here, will be maximum. First, the UDL. UDL is 0.2
3.5.
and it is present on the whole area. So this area minus this area. That area is, the plus area is 3, 1 over 2 into 3 into 0.75 minus 1 over 2 into 0.5
5.
into 1 plus. Now due to this point load, when you will get the maximum moment? When the load is
At B.
which point?
B.
Here or here?
B.
B.